ionic equations. So ionic equations follow simple rules. They follow simple rules which you need to pay particular attention to. So basically, what are ionic equations? So you see, in each and every chemical equation, you have a lot of compounds, a lot of elements involved, but there are specific elements or ions that are involved in that particular equation. Then you have to remove those that are not fully participating in a chemical equation. So the first rule is that number one, make sure that you write a balanced chemical equation. Write a balanced chemical equation. So the equation that you are dealing with must always be balanced. Make sure your equation is balanced. Then once you write your balanced chemical equation, you must be able to split or break compounds into their respective ions. So I have to add here that you are only supposed to split ions or compounds that are split only compounds that are in aqueous state. Only those that are in aqueous state, the rest don't touch them. I repeat, split only compounds that are in aqueous state. If it is in solid state, don't split it, leave it as it is. If it is in liquid state, leave it as it is. If it is in gas state, leave it as it is. The only compounds that you are splitting are those only that are in aqueous state. Then once you have split those compounds that are in aqueous state, then you move to step number 4, where you must be able to cancel out spectator ions. So spectator ions are those elements that are not taking part in a chemical reaction, so those can be cancelled out. Then the last step now is write the remaining ions. Write the remaining net ionic equation. So whatever remains after you've cancelled out that is what you write. So on cancelling, you're only cancelling those that are appearing on both sides. The ions that are appearing on both sides, those are the only ones that you are cancelling. So for example number 1, if you have say a reaction between sodium hydroxide, which is in aqueous state, that is reacting with hydrochloric acid. This also is in aqueous state. Okay, then this will produce sodium chloride, which is also aqueous state, and water. So water is in liquid state. So now that you have this reaction, your next thing is now you are supposed to write step number 1, write a balanced chemical equation. That is step number 1, write a balanced chemical equation. So here we have to confirm whether this equation is balanced. So if you don't know how to balance chemical equations, you can watch the videos that we have done on how to balance chemical equations. So right now we're just going to go straight and confirm whether this equation is balanced or not. If it's not, we'll balance it. Okay, so sodium here we have 1, this side we have 1, oxygen we have how many here? 1. How about there? We have 1. Hydrogen we have 1, 2. So we have 2 hydrogens. What about there? We have 2 hydrogens. Chlorine we have 1, 1. So our equation is balanced. So step number 1 is done. Then we move to step number 2, where we are taught to split compounds into their respective ions. So number 3 here is emphasizing to say we are only supposed to split compounds that are only in aqueous state. So we have to identify which elements or compounds are in aqueous state. So from our equation, sodium hydroxide is in aqueous state, so this one has to be split. We have hydrochloric acid here, which is in aqueous state, so we have to split it as well. Then we have sodium chloride here, which is also in aqueous state, so we have to split it as well. Then we have water, which is in liquid state. So water, we are not going to touch it because it is not in aqueous state. So we are primarily focusing on the compounds that are in aqueous state. So let's move on to now splitting. So we are going to split these into their respective ions. So we have sodium ion. So remember that sodium has a valence of 1, and this is a metal, so we are going to give it a plus. The symbol or the state has to remain as it is. Then we have OH, which is hydroxide. This one is negatively charged, so we'll write it like that. Then next we have this other compound. So for the first compound we are done. We have managed to split this into its respective ions. So here we go. Hydrogen is positively charged. Okay. Then what about chlorine? Chlorine is a non-metal that is negatively charged. Okay. Then we are done here. We move to the other side. We need to split sodium chloride. So sodium chloride, as we have seen from the onset, sodium is a metal, so this one is positively charged. So pay attention to where I'm putting the ions. Then you move on to the next one, where you have Chlorine as well is negatively charged, so you write it like that. Okay, so water, we are not going to tamper with it. This one will just bring it the way it is. Okay, so this is water. So now step number 4, cancel out spectator ions. So what are these spectator ions from our equation? So we are looking for ions that are found on both sides of the equation. So the reactant side here, we need to look out for ions that are also found on the product side. So is sodium ion found on the product side? The answer is yes. So this one, we'll cancel it. We'll also cancel that one. Then we move on to the next ion, which is hydroxide ion. Hydroxide ion, is it there? So we can't see it. So there's nothing like guessing. If it's not there, it's not there. So there's nothing like, where am I going to find it? What am I going to do now? No. So if it's not there on the other side, don't cancel it. You leave it at that. Then you come to hydrogen ion. Do we have hydrogen ion on the product side? There's nothing. So you leave it out as well, just like that. Then you come to chloride ion. Chloride ion, which is chlorine ion, chloride ion. So do we, on the reactant side, we have chloride ion? Do we have chloride ion on the product side? The answer is yes. So this one as well, we cancel it out. Nicely like that. So this one has been cancelled. So the next thing now is to simply copy whatever has been left out. Anything that you haven't cancelled, you bring it down. The way it appears, you follow it nicely. So the reason why we have to deal with the balanced chemical equation, even at each and every step, we must ensure that whatever atoms that are involved are balanced. So if you make a mistake anywhere, you will realize that your equation somehow may not balance. So we have to still be able to obey the rule that all the atoms that are involved in a chemical equation must be the same. So this is the reason why we must always make sure that we are working with an equation that is balanced. So this is what we have now. Okay, so here you have hydroxide ion reacting with the hydrogen ion to produce water. So this is our equation. This is our balanced chemical equation. So this is our net ionic equation. So if this is what you've written, then this is correct. So let's try to have another example. Example number 2, we are going to look at sodium metal that is reacting with hydrochloric acid. This will help us produce sodium chloride and hydrogen gas. So now sodium is a metal, then we have hydrochloric acid, which is in aqueous state. Then we also have sodium chloride. This is a salt, which is also in aqueous state. Then we have hydrogen gas, which is in gas state. So now, following our steps, when you are writing an ionic equation, the first step says write a balanced chemical equation. So let's confirm whether the equation that we have is balanced or not. So now, sodium, we have one atom of sodium on the reactant side and one atom of sodium on the product side. Hydrogen, we have one atom of hydrogen on the reactant side and two atoms of hydrogen on the product side. Then chlorine, we have one atom of chlorine and 1 atom of chlorine on the product side. So now what is not balanced is hydrogen. So if we try to balance hydrogen will affect chlorine as well. So meaning for us to balance chlorine, we need to add a 2 there. When you add a 2, it means that even sodium will not be balanced. So to balance sodium, we need to add another 2 there. So implying that we have 2 atoms of sodium that is reacting with 2 atoms of hydrochloric acid and 2 moles of sodium chloride and 2 moles of hydrochloric acid. So now this equation is balanced, so the first step is satisfied. Now the next step is to identify compounds that are in aqueous state. Identifying compounds that are in aqueous state. So sodium, this is a metal, it is in solid state. Hydrochloric acid is in aqueous state, so this one we take note of it. Then sodium chloride is in aqueous state, we also take note of it. Then hydrogen gas, this one is not in aqueous state, so every compound or atom or element that is not in aqueous state, that one will not tamper with it, will just leave it at that. So now that we have been able to identify compounds that are in aqueous state, we need to move to step 3, where we are told to split compounds that are in aqueous state into their respective ions. So now we are going to say sodium. This one is in a solid state, we just copy it the way it is. So we have 2 atoms of hydrogen. So hydrogen, when we split it, it is going to be hydrogen ion, which is in aqueous state. Then we also have 2 atoms of chlorine, so the name changes to chloride, which is negatively charged. This one also is in aqueous state. So we are done on hydrochloric acid. We move to sodium chloride. So we have 2 atoms of sodium, so we're going to say sodium ion, which is in aqueous state. Then the next compound is chlorine, 2 atoms of chlorine, they must appear as such. Then this one also is in aqueous state. The next one is hydrogen gas, so this one we'll just copy it the way it is. The way it is, just like that. So now we have to compare. We'll look for we are cancelling now number 4. We'll cancel out spectator ions. So spectator ions are those ions that are found on both sides of the equation. So on the reactant side, we have to look out for ions that are also found on the product side. So sodium and sodium ion, these are 2 different things. So this is sodium atom and this is sodium ion, so you do not cancel, because this one is not an ion but this one is an ion, so these are not the same, so you do not cancel. Then when we come to hydrogen ion and the hydrogen atom, these are also 2 different things, so you don't cancel them out, you leave them as such. Then the other one is chloride ion. So chloride ion and another chloride ion, these are the same, even the way they appear, they are the same, so those you cancel them out. Now that you have cancelled out spectator ions, you move to step number 5, where you are expected to rewrite the remaining net ionic equation. So you are going to just copy everything that you haven't cancelled out. So sodium in solid state, then you move to hydrogen, which is in aqueous state. Then you move to what else is remaining there. You have sodium ion, which is in aqueous state, and hydrogen gas, like that. So this is our net ionic equation. our simple net ionic equation. Thank you very much for watching and hope you enjoyed it, and I can request you to practice more so that these things become normal. Thank you very much.